this video, we will work on solving systems of equations by elimination using multiplication. First, let's review the steps to solve a system of equations with eliminations. First, line up the like terms vertically. Equal signs should be lined up as well. If the x or y terms are opposites, then add the equations together. If the terms are not opposites, multiply one or both equations by a number so that there are opposites, and then add the equations together. You should have as a result one equation and one variable. So you can solve for the variable. Substitute into one of the original equations to find the other variable, and finally write your answer as an ordered pair. Our example gives us the system negative 10x plus 2y equals 24 and negative x plus 6y equals 14. If I want to solve the system, you can choose to go about it a number of different ways. If I wanted to make the x terms cancel out, I notice that if I multiply the bottom equation by negative 10, it'll give me, so my original equation will stay as negative 10x plus 2y equals 24. And if I multiply everything in that second equation by negative 10, I'll have positive 10x minus 60y equals negative 140. Now if I add those two equations together, negative 10x plus 10x gives me 0x. 2y minus 60y is negative 58y. And 24 minus 140 gives me negative 116. Now that 0x cancels out and I don't have to write it. So my equation is really negative 58y equals negative 116. To solve for y, I would divide both sides by negative 58 to get y equals 2. Now I can plug that back into one of the original equations. So if I plug into the first equation, I have negative 10x plus 2 times 2 equals 24. If I solve that equation, I'll have negative 10x plus 4 equals 24. Subtract 4 from both sides to get negative 10x equals 20, and divide both sides by negative 10 to get x equals negative 2. So the solution to this system is negative 2, 2. Our next example gives us the system 4x plus 2y equals 6 and 10x minus 10y equals 0. If I want to make the y terms cancel out, I can multiply the first equation by 5. So if I multiply every term by 5, I'll get 20x plus 10y equals 30. My second equation will stay the same. So I'll have 10x minus 10y equals 0. Now if I add the two equations together, I'll get 30x, 10y minus 10y gives me plus 0y equals 30. And remember that 0y cancels out. So my equation becomes 30x equals 30. To solve for x, I divide both sides by 30 to get x is equal to 1. Now I can plug that into one of the original equations. If I plug into the first equation, I'll have 4 times the value of x, which is 1, plus 2y equals 6. If I solve, I'll have 4 plus 2y equals 6. Subtract 4 from both sides to get 2y equals 2, and divide both sides by 2 to get y is equal to 1. So the solution to this system is 1, 1. In our first example, we have the two equations 3x plus 8y equals negative 8 and 5x minus 3y equals 3. Now, we are going to have to multiply both equations. So you could choose to either solve for the x or the y. In this example, I'm going to choose to solve for the x. So if I multiply the first equation by positive 5 and the second equation by negative 3, and again, I have to multiply every term. So my first equation would become 15x plus 40y equals negative 40. And the second equation, if I multiply every term, becomes negative 15x plus 9y equals negative 9. Now if I add these two equations together, the 15x minus 15x will give me 0x plus 49y equals negative 49. Now again, that 0x doesn't have to be written. So my equation really is 49y equals negative 49. To solve for y, I would divide both sides by 49 to get y equals negative 1. Now if I substitute that value of y back into the original equation, the first one, I'll have 3x plus 8 times negative 1 equals negative 8. Now if I solve, I'll have 3x minus 8 equals negative 8. Add 8 to both sides to get 3x equals 0, and divide both sides by 3 to get x is equal to 0. So the solution to this system is 0, negative 1. In the next example, I have the equations negative 7x plus 9y equals negative 19 and negative 4x plus 6y equals negative 10. Again, in this equation, I'm going to have to multiply both of the equations. So if I choose to make it so the y terms will cancel out, I could multiply the first equation by positive 2 and the second equation by negative 3. Now if I distribute that 2 throughout the first equation, it'll give me negative 14x plus 18y equals negative 38. If I distribute the negative 3 to the second equation, it'll give me 12x minus 18y equals 30. Now if I add those two equations together, I'll get negative 2x plus 0y equals negative 8. And again, I don't have to write that 0y. So it's really negative 2x equals negative 8. If I divide both sides by negative 2, I would get x is equal to 4. Now if I plug that value of x back into the first equation, I'd have negative 7 times 4 plus 9y equals negative 19. If I solve, I'll have negative 28 plus 9y equals negative 19. Add 28 to both sides to get 9y equals 9, and divide both sides by 9 to get y equals 1. So the solution to the system is 4, 1. In this video, we will talk about special cases of solving systems of equations with elimination. First, if the system results in a true statement, then there is infinitely many solutions. So for example, you could have 5 equals 5 would indicate infinitely many solutions. If the system results in a false statement, then there is no solution. So if you use something like 4 equals 0, which isn't true, then it would be considered no solution. In our first example, we had the equations negative 6x plus 3y equals 25 and 12x minus 6y equals negative 30. If I multiply the first equation by 2 and I distribute that 2 to everything in the equation, you'll get negative 12x plus 6y equals 50. And the second equation stay the same. So it's 12x plus minus 6y equals negative 30. Now if you add those two equations together, you would have 0x plus 0y equals 20. Now I don't have to write that 0x or the 0y. So that really means that it gives me 0 equals 20. Now we know, looking at this, that this isn't a true statement. So since this is false, it indicates no solution. In the second example, I have the equations negative 6x plus 8y equals 18 and 9x minus 12y equals negative 27. Now if I wanted to cancel out the x terms, I can multiply the first equation by 3 and the second equation by 2. So if I distribute that 3, it'll give me negative 18x plus 24y equals 54. And if I distribute the 2 for the second equation, it'll give me 18x minus 24y equals negative 54. Now if you add those two equations together, you'll get 0x plus 0y equals 0. Now I don't have to rewrite the 0x or the 0y. So it really means it gives me 0 equals 0. Now since this is true, that means that there's infinitely many solutions.